Well, hello guys and welcome back to Mr. G Physics, the channel that is going to help you or can help you to improve your marks and physical sciences. This is Mr. G and today we're going to be doing a question on vertical projectile motion for the grade 12. This topic is not that bad, but it can get confusing. If you didn't subscribe, don't forget to subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question says a stone is thrown vertically upward with an initial speed of 10 meters per second from the rooftop of a 80 meters high building. When it falls back, it falls past the edge of a building directly to the ground. Ignore the air resistance. Okay, so let's first of all have an idea of what is going on here. We have a ground and there is a building on the ground. This building is 80 meters height. So from this point to this point is 80 meters. A ball is thrown vertically upward from that building. So that ball was thrown vertically upward with an initial velocity equal to 10 meters per second. Alright, and obviously to go all the way up, and eventually I'm going to do it on the side here, eventually that ball will return to the ground, all the way to the ground. So eventually that ball will reach that ground with velocity which we don't know. Okay, now the question 2.1 says explain the terms projectile. So what is a projectile? It's an object that moves under the influence of gravitational force only. So the only force acting there is gravitational force. Guys, this is 2 marks for this definition, and remember we said before the only 2 definitions you have in these topics are projectile and free fall. Question 2.2 calculate the maximum height attained by the stone above the ground. So the maximum height above the ground, guys, is this one here. This is the height from the ground. This is the height from the ground. That is what they want. We already have 80, but we don't know how far the stone went from the top of the roof. So that is what we are going to calculate. All we are going to do is to quickly calculate how far from the ground this stone went up. This one here is what we are going to calculate first. Okay, so for this one we're going to edit the data, which part of it is already on the drawing, but we're going to select the direction. So before even we start writing data, we're going to write here up positive. Remember, this is entirely up to you. I'm going to decide up positive, but it could be down positive. Okay, so the initial velocity is equal to positive 10 meters per second because it is up. What are the data we have? The velocity at maximum height is equal to 0. Okay, you need to know that the velocity of that projectile at the maximum height is going to be equal to 0. We have the acceleration due to gravity is equal to minus 9.8 meters per second square. Minus because it is pointing down, and then we are looking for the displacement. Okay, so this is the data we have. Okay, so now what we're going to do, we're going to go to the formulas, and because this is a test, you have the formulas there. All we have to do is to select which one according to the data we have is going to help us, and in this case the one that can help us is this one here because we have all the data given to us. So we come here, we write the formula, and final speed square velocity square is equal to initial velocity square plus 2 multiplied by the acceleration due to gravity multiplied by the displacement, and the rest is substitution. I'm very careful with that one. So the answer here is 5.10 meters. This is the maximum height from release point. The question says maximum height from the ground. So the maximum height this object reaches from the ground will be the addition of 80, which is the height of the building, plus this displacement, which is 5.10. So the maximum height is therefore going to be 85,10 meters. No direction needed because that one is a scalar quantity. That is the answer of the question. Now let's give marks here. And this question has 4 marks, as you can see there. So 1 mark would be for the formula, 1 mark will be for the substitution as long as the directions are correct. That means that 9,8 must be a negative or positive, and then the velocity must be negative. It's according to the direction you select. This 1 mark for adding 80 plus 5,10, and then is 1 mark for the final answer, guys. This is 4 mark for this specific question. Now we're going to the last one. They say calculate the time taken by the stone to reach the ground. And this is something important I want to point out here. When this stone is starting from initial position, which is this point, which is the releasing point, the final position of the object will be at the ground level. That is the final position of that projectile. So the displacement of this object was from starting point to end point. This one here, guys, is the displacement of the object, the total displacement. Right? So saying that, we can then calculate the time for that specific displacement then. So let's go back to question 2.3 and write all the data once more so we understand. We once more want to say up is positive, and then what we have, y is negative 80 meters. The displacement is from starting to end, and you can see that is a vector pointing down. Something important, this one is 80, no 8. So let's quickly fix it here. This is 80 meters. Sorry about that. So the displacement is pointing down, guys. It's in opposite direction. I say up is positive. And then we are looking for time. Okay? So we once more go back to the equation, to the formulas of motion. And which one are we going to use, guys? This one have all the data we need to calculate. So we come here and then we write the formula. Displacement is equal to initial velocity multiplied by time plus half acceleration multiplied by the time square. And the rest is substitution. If we rearrange this equation we have, and guys, this is mathematics, you can have an equation equal to ax squared plus bx plus c equal to 0. This is a quadratic equation. Now, why Mr. Gomez, why Mr. G, you go through that, all that work? Well, guys, the main marks are here. I took this route because there is 1 mark for the formula, there are 1 for the substitution on the right hand side, and 1 for the negative 80 on the left hand side. So out of 4 marks, you already have 3 by just substituting. That is why I took this route. All the calculations that we're going to do, it takes only 1 mark. I'm not saying you mustn't take that mark, I'm saying you mustn't struggle, and because the exam is really long. So now we're going to use this equation of mathematics. X from here is equal to minus b plus minus square root of b square minus 4ac divided by 2a. And you will have 2 options here. Remember, time cannot be negative. So you come here, you say that time is equal to and then when you try both of them, you get that the time is going to be equal to 5,19 seconds. That is the correct answer. If you try both of them, you will get 1 negative. That is not correct, and this one is the final answer. What I said, there's only 1 mark for that one. Guys, this is the question we practice. I hope you understand. I hope it helped. If it helped, subscribe for the channel. Next time we're going to try to solve this question 3 and then later on a question 4. This is a test developed for the learners to practice projectile, and then I thank you very much. I'll see you next time. Mr. G here.